Hi. Okay, today we're gonna talk about systems of equations. We talked about this yesterday a little bit. I gave you some examples. Um, Today we're just gonna talk about substitution and elimination. Um, Whenever you're using a system of equations, you are comparing two linear functions and seeing where the solution is and if they have a solution. So when one equation is set equal to a variable, pen's not working, variable, there you go. The first thing you need to do is substitute the isolated variable into the other equation. So we're going to do this as we go. So first thing I need to do is to substitute this y, this right here, and for this y. So you're going to have, this is step A, 2x minus 3 times, and this is what you're plugging in, x minus 1 equals negative 1. Okay, now what you're going to do is you are going to use the distributive property. So you're going to, in order to do that, you have to, you're solving for one variable. So this is us solving. So you're going to distribute that right there. So you're going to have 2x minus 3x plus 3 equals negative 1. And then you're going to combine like terms. So you've got 2x minus 3x, which is negative x plus 3 equals negative 1. Okay, and now you're just simply solving for x. So you're going to subtract 3 on both sides. You'll have negative x equals negative 4. And then x equals 4 because I've divided by negative 1 here on both sides to get rid of that negative sign. So x equals negative 4. So this is our step B. And then step C is to plug the solution into the other equation to solve for the other variable. So you're going to plug in x equals 4. It doesn't really matter which equation that you plug it back into, but I suggest plugging it back into the easiest one, which is right here. So y equals x, this is step C, y equals x minus 1. Then you're going to say y equals 4 minus 1, and then y equals 3. So your solution to this system of equations is x is 4 and y is 3. Now remember, whenever you're solving for a system of equations, this is how it looks. You're looking for that ordered pair to see where it intersects. And it's going to be an x and a y, an ordered pair. So that is substitution, where you substitute in for one variable. Now it says you can use whenever one equation is set equal to a variable, but you can use it with both of them whenever it's in standard form or in slope-intercept form. So this next one, elimination. Use when both equations are presented in standard form. Now, like I said earlier, you can use it for both of them. So we've got standard form. Okay. And then you set equations up like an addition problem. So you're just going to simply combine those two equations together to eliminate one of your variables. So your whole goal here is to eliminate one variable and then figure out what that first unknown variable is, and then plug that known variable into the other one. So on this one, this is real nice because it has a negative 4x plus 4x. So if you were to combine these, negative 4x plus 4x is 0x, and then negative 2y plus 8y is 6y, so plus 6y, and then that equals negative 36. And from this we can divide by 6 on both sides, and y equals negative 6. Okay, so we've set them up like an addition problem, that's A, and then B solved for one variable, and now we're going to plug the solution into the equation to solve for the other variable. So we've got y equals negative 6. So let's do 4x plus 8 times negative 6 equals negative 24. Okay, now you're just solving for x. So 4x, and this is step C, minus 48 equals negative 24. Okay, now you're still solving, so you're going to add 48 to both sides. 4x equals 24. And then you're going to divide by 4 on both sides. And then x equals 6. So your solution here is going to be x is 6 and y is negative 6. Okay, and this is the elimination method. It eliminates one of the variables and then you plug into the other. Okay, I hope these examples helped you a little bit. We will be doing some practice in class, and then we'll probably start a PRBL the next day or so. Okay, have a great night.